Morning, everyone. Welcome to the next installment of the JKMRC Friday morning seminar series that take place here at the Indurpilli Lecture Theatre, as well as online. My name is Katerina, and myself and Karina are the co-hosts of the seminar series and are taking turns introducing the speakers this year. On behalf of the University of Queensland and the Sustainable Minerals Institute, we'd like to respectfully acknowledge all traditional owners and their custodianship of the lands on which we all meet today. We pay our respects to their ancestors and their descendants who continue cultural and spiritual connection to the country, and we recognize their valuable contribution to Australian and global society. Our today's speaker is one of the most recent additions to the SMI and BRC family, Professor Nick Cook. And Nick's professional and personal accomplishments are so numerous that it may take a seminar in itself to list them all. So I just have to cherry pick a few. Nick's career includes periods of university research and teaching, mineral exploration, as well as a finance professional. And he joins the BRC as a program leader of the Total Deposit Knowledge Group. And prior to that, he was chief geologist for Mawson Gold and technical advisor for Southern Cross Gold, both of which were global roles that combined ore deposit discovery with responsibility for international collaborative research projects between industry, government, and universities. Nick has proudly been an industry supervisor for PhD, master's, and honors projects across Finland, UK, and Australia. And all of this is in addition to continuously providing training for internal and external geologists. And I, for instance, have also taken part in one of Nick's courses several years back. So with this in mind, today's seminar is titled Total Deposit Knowledge, Getting the Most from Exploration and Mineral Deposits. Let's welcome Nick.
Thank you, Katerina. Thank you very much for joining me. It's a privilege to be here and on this side of the screen instead of the other side for the last few years watching. So as Katerina said, I'm one of the more recent additions to the SMI team. So I'd really like to talk today about the role of total deposit knowledge, but more how it fits in with what we see as our role in the industry or the discipline right across the full Sustainable Minerals Institute. In other words, across the whole mining cycle. So I've given, I don't know how many talks at various places over the last 20 years, or the last 2 to 20 years, but I wrote this from scratch with all sorts of history here. I'll just get back to make the screen live. So I've written this from scratch. So there are bits and pieces taken from the wonderful people I've worked with over the last N years, because I don't want to give away how old I am. But I'm actually privileged here now at University of Queensland that I joined 2 other professors from the University of Otago from the early 80s. So that probably gives most of it away. So a little bit about me to start with, so you understand sort of where I'm coming from. I was actually born in London and then moved when I was 3 to south of Dunedin to a little town of 400 people where my dad was the local GP. I went off to the University of Otago in Dunedin, 1981 to 84, and had keen interests in the hard rock world, I suppose. Not so much in economic geology, because the southeast corner of New Zealand at that stage, when we went to Macraes, we looked at a couple of old quartz veins and didn't look at what is now a 10 million ounce or so wonderful deposit down there. I had a little gap where I worked on a boat off around Stewart Island for 7 months and then moved to Australia. And along with that came my 3rd passport, which I still cart around. And I did a part-time PhD there where I worked on the O'Leary block out west of Broken Hill and tried to work out what was going on with those rocks. Had a few other projects along the way, including some orogenic gold projects. In fact, my very first consulting job in Australia was on Ngambie before it became a mine. And I ended up all the way back there some 30-something years later in the last couple of years. But I also worked on Aboriginal rock paintings and the stability of the colours involved in that. Had a stint in Antarctica, and I'm also love flying. And because I commuted backwards and forwards to Finland, I suppose that was a good thing. I started a postdoc, and I have to say then I found the university system a little bit more than I wanted to be in, I suppose you'd say, and went off to Broken Hill as an exploration geologist, and then Parkes, then Brisbane, the classic 7 houses in 7 years, moved around, got married at the same time I got made redundant, so my wife understood the minerals industry, the ups and downs very quickly. And then I had an interlude as a finance professional, as I mentioned before. I couldn't keep myself away from rocks, basically, and started back into the exploration industry as a consultant in 2011. 2013, we lived in Finland, in Helsinki for the year, and I was basically the technical team lead for the last 10 years involved in Mawson Gold and Southern Cross Gold for the last couple of years. Also an honorary lecturer at the University of St Andrews in Scotland. And then 4 weeks ago, here I am at SMI. So where are we going with this seminar? I'd like to look at how total deposit knowledge actually fits in with the Sustainable Minerals Institute and our view of perhaps how we actually fit in a role of exploration and geologists into how people think about our business at the moment. Total deposit knowledge, I would say, could be broken down into 3 basic parts. We could use 3 words to describe what our role is. We find it, we describe it, and we predict. But over the top of that, we should always remember that we have an education role here. And that education role I will develop later a little, but it is education, one, of the people like you, but then it's education of the people out there that we actually need to support our business. So we need to be able to provide tools out to the world that actually gives us support for what we believe in. So we don't want to be continually preaching to the converted, because that's the easy stage. We want to be able to, I suppose, go back against misinformation and things like that, but actually provide tools where we can do that at an appropriate level. So let's get into it. One of my favourite photos in many ways, way back to Apollo 8. And I suppose it looks pretty small in this view. And I suppose my thought generally relates to when I wanted to be an outdoor scientist. I had no idea that I was going to do geology until year 12. And I wanted to do some sort of outdoor science. And even then I realised that the human footprint on this planet was increasing. And we all know the current effects of that. And I'm not going to enter any of those debates other than to say, basically, don't poo in your own nest. Where do we fit in? So the Sustainable Minerals Institute has over 170 academic staff and 130 graduate students. And I form a part of the Bryan Mining Geology Research Centre. And I'll come back to how we actually fit in that group as we go on. So we have some wonderful people within the BRC. This team, led by Anita, My Watch, Mine Waste Transformation through Characterisation. In other words, can we actually predict from rocks what will happen to them? And very importantly, at the far end there, we have lots and lots of tailings out there that we should be dealing with in an appropriate way and thinking about what metals are there and how they affect our environment. We have Andre here in the Deep Mining Geoscience group. How can we effectively get this material out at depth, both from a cost point of view and, more importantly, a safety point of view? Now, one of the things that I interestingly thought about as I started this process, I sat up in the boardroom and I looked around, and the whole wall was dominated by what you'd call engineering. In other words, us modifying the surface. And I thought, I'm not sure yet that's the message we should be putting out there. So I'd like you to think about our messages and how we actually portray what we do in our business in terms of the messaging of mining and things like that. I mean, I'm proud of engineering and things like that, and I have a different view, I suppose, from many, but it's not us that actually matters in terms of the support for our business. We also have groups that actually work right across outside BRC and go across the different platforms. And I've put this up to give you an idea of the scale of what we do. And it goes right from the start to the end of the process. And can I get this to go through? And there's lots and lots of words on here. And I'd like to deal with a couple of these parts of the process in terms of TDK, total deposit knowledge, as we go. Cooperation here is one of the keys to our business. Now, I love flying, so the idea that drones would start appearing here and be able to solve some of our problems is fantastic. And there's lots to do in that space, because a low footprint is a great outcome. So we have this project that runs across our business. So what about how we as a group fit into the mining cycle? Here's one of our colleagues in northern Finland looking at the aurora on a cloudy night. So we have this classic circular view, I suppose, of what we do. So we have project generation. We have a stage before we actually discover something. We have discovery. We assess what's there in terms of feasibility, development, mining, rehabilitation, and mine closure. And so in terms of imagery, this is the process. And my colleagues here from Finland will appreciate this. Just published our preliminary economic assessment as a news release last week. Congratulations. So that was 10 years of my business, and Ivan, their CEO, is in the audience here. But essentially, we need to remember that we go all around to the top left, and that is a key part of our business. So there's other views of the mining cycle out there that people look at and think about. The Lassonde curve, for example. Now, it says up the top that this is actually the life cycle of a mineral discovery, but I'm not sure this is the life cycle of a mineral discovery in many ways, because it's actually controlled by the magic dollar on the left. And furthermore, you'll see it finishes with the operating mine. Now, that to me is a really poor way to sell our business. It's great if you're an economist. It's great if you're an economist. And there was a discussion the other day with some larger mining companies about the fact that the big question mark off to the right is often not properly assessed in the early stages of our business. So in the discovery stage, we don't tend to think about it enough. It doesn't get planned. In fact, we almost hope it can be sold to somebody else so that our revenue stream is not interrupted by the thought of having to close the operation, or to have to get somebody like Anita's group to come in and the other people to come in and clean up the mess that has been made. So another view of this mining cycle is to go to the European view, which started like this. It was pretty unfortunate that in the initial stages of the European view of the mining cycle, that magically the metal appeared and we went round in a circle and there was actually no waste. And fortunately, my colleagues at the GTK, the Geological Survey of Finland, fought with other people to actually improve this circular economy, which is probably not an economy either, but into a shape that was more realistic for population growth and metal use. So another really good way to think about how we operate our business. So how do we fit in the SMI? So this is another way of looking at that big table, that we actually have a group of people, and I put them in the middle, but they're all encompassing, who actually deal with our business all the way through the life cycle. Don't forget that we have partnerships with other programs, UQ faculties and external parties. So where does TDK, the Total Deposit Knowledge Team, fit into this? Well, we have these three parts of it. The find it part, project generation, pre-discovery. We have to describe it properly, but it's no use describing it if we can't actually predict the behaviour through the whole mining cycle. So every part of our business should actually be thought about in terms of how we actually deal with this part of our world. Oops. So some wonderful images here about what we're actually doing in terms of production. So 2021, this is from the Visual Capitalist. If anybody's interested in really cool diagrams about impacts and social license and population growth and those things, I'd recommend this site. So 2.8 billion tonnes of metals mined in 2021. And you can see the transition down here to things that we regard way down here in the bottom right as critical metals and really, really important for the modern technology. And it's really unfortunate in many ways that this is a volume diagram, not a value to modern society diagram. And I suppose I'd argue that one thing we should do is turn this around so that we actually start dealing with impact rather than volume. So how can we in our teams actually build this to educate the public as to what the impact of this is in terms of a lower carbon economy, for example? Don't forget that the metals mined are actually only 10% or less of the industrial production. So industrial materials, which is mining also, but tended not to be regarded as that, is 10 times bigger in volume. And interestingly, the approvals process for a lot of these things around the world is a completely different equation to what we do, and yet the footprint is probably much larger. So let's delve a little bit into the find it part of the world. And my first question is, how good are we at it? And if you look at the metals industry versus the oil industry, for example, our success rate is pretty awful. So as geologists, it's embarrassing to say in many ways that we spend an awful lot of money missing our targets. And we should get much better. Now, I'm not glossing over the fact it's a really hard job and really hard to actually achieve that. But another question is, are we engaging with the right people so that if we do find something, we'll actually be able to do something with it? So there's some questions here. Project generation. So we have people start thinking at the continent scale as to where they go. So there's actually no ground contact at that stage. There's a whole question of permitting time. And one thing to remember is there's really two groups of exploration people out in the world. There's the big companies and there's a whole bunch of junior companies. The big companies require basically rely on productivity from their mine sites to fund what they're doing. And the junior end of the business relies on the market, the finance markets. And so you will see times when the junior exploration business is destroyed by something that seems completely unrelated, e.g. cannabis production. You would never think there was a link. But because people think that they can make more money out of cannabis production, they will put money into that and starve exploration businesses. And as they starve the exploration business in terms of the junior world, the time that it actually takes to find things is extending. So we need to be careful about how we retain support in that side of the industry in particular. So we drill, spend lots of time. We have a whole bunch of human observations when we come to drilling. And then we have complex machine-derived data from our drill holes. And lots of the people that we have here are super, super good at the complex machine-derived world. And other people are excellent at the other end. And then some people can actually combine the two. Now, we need to make that machine and human interface much better, because the general outcome is still that we miss what we're aiming for. And you'll hear geologists and exploration people say this all the time: it was a near miss. Well, our Finnish colleagues used to say it was a near hit. That was the positive view. The cup was half full. So we nearly hit it. But we want to make sure that the data that we're collecting at the moment tell us whether it was a near hit or how far we were away or something like that. Now, over the right here, I've put this arrow about ESG engagement. Engagement is incredibly important from the start, because if you actually get to this stage and you haven't started the ESG process, it is too late. By the time that somebody drives down the road and sees 5 drill rigs in a row, that creates opposition because of lack of knowledge. So we need to get better in our business at thinking like that. And it depends where you are as to what stage you actually do that. So when I lived in Broken Hill way back, there was a drill rig in the middle of the school grounds with a fence around it. And it was there for 2 years drilling holes. Of course, everybody in Broken Hill thought that was fantastic. But if you did that in Kenmore, I'm not sure the outcome would be the same. And we actually need to think why that is. I mean, there's obvious answers. So where are we going in this whole world? So the difficulty and risk in going to this low carbon economy is really great at this stage. And at the moment, when we're saying we want to go towards 2030 and reduce our carbon footprint by X and go to 2050 and have net zero, there is a desperate need to find the metals to make that happen. But the other alternative is to effectively use what we have already. And one, that's where mine waste characterisation comes in. I don't know what the actual volume of tailings in Australia is. Anita might know that answer, but it's huge. And they contain a huge amount of what we might call useful metals to a low carbon economy. And the system keeps going in terms of difficulty and risk, but perhaps the next stages are engineering and more gradual improvements, because we can actually already do most of the things that are after the exploration stage. We know how to get them out, even though it might be quite intensive in terms of energy. So our BRC, or Research Centre framework, revolves around discovery, measurement, modelling, prediction, reconciliation. Reconciliation is generally associated with the metal in the mine equals a prediction of what we actually did. It should be more than that. It should actually be the whole process. So what happens in terms of reconciliation with the tailings versus what we actually predicted from the drill core at the start? I think we actually need to broaden that out past whether we got back the copper and gold we actually thought about at the start. So here's our wonderful Finnish and actually Swedish geologists here standing in Rovaniemi. And this is the first stage, I suppose, of the excitement in exploration. We get back our drill core and somebody sees the metal that we're looking for. And this is an unusual case working in this part of the world. As I said to somebody yesterday, the core arrived and it was minus 30 degrees. So as an Australian geologist putting water on it first, it turned to ice. And the Finns all laughed at me and said, you need to learn some more. So you have to defrost it before you actually do anything with it in the morning. But that aside, we need to look at the core and work out what to do. Now we get assay data back. And I suppose my question is, what do we do with our assay data that we get back? Now this is a wonderful intersection part of the Finnish project. And this is gold and cobalt results in drill core superimposed on our box here of boxes of core. And geologists get even more excited when they look closely at rocks with their hand lenses. And here we have chalcopyrite, pyrrhotite, cobaltite, a cobalt arsenate mineral in the rock. And so we produce a number and we tell the world that we had 23.6 grams per tonne of gold and 1.46% cobalt in this rock. Now, everybody gets excited. But the whole question is, how do we get it out? Is it worth getting it out? Do we get paid for it? What's the waste? All of those things that we actually need to consider carefully from this stage of the process. Now, some of the people here, I'm already preaching to the converted, but I actually want to think you guys to think about how we actually start telling the rest of the world that needs to support us in this stage. And we can look at the core in so many different ways. So we can look at the spectral response. So here we have the spectral response to one of those pieces of core from the previous photo. Up the top here, you see where it says VG. Doesn't stand for very good, it stands for visible gold. And strangely enough there, the brown piece is actually lower temperature white mica. And why is that important? Well, that is a correlation that would actually give you some information about where to go next. But actually dealing with the machine and going back to deal with the combination of the geological views is not that easy, because the intervals sometimes that we are measuring don't correlate with the observations. So there's always this scale difference in what we do as geologists that makes it a little bit harder. So the end result is a beautiful image to many of us like this, where we imagine our mineralisation heading down into the ground, and we come up with a number and we say, this is the answer. Well, it is the answer in many ways. It's the first answer in a long stage before we actually proceed. Which brings me to this part that I call resource efficiency. So what are the steps to decide on the progression of a project? There's description and modelling leading to the ultimate question for many. Does it actually make any money? And we tend not to think like that as geologists, perhaps, unfortunately, unless we've worked in the mining game. But I suppose even more importantly, what parts of it actually make money? And how do people actually look at it? Well, what tends to happen, for example, is that we get out our big Excel model and we have this wonderful function in there called goal seek. and we set the net present value to be 250 million. In other words, that's the return we'd like to get on our project. And we're going to change the production rate to get to that value. Now, that happens lots and lots and lots of times. The question is, the bigger production rate equals a shorter mine life, and it leads to a better financial result. But is that actually any good for sustainable development? Because essentially what we're doing through that model is actually to send it out to the tails or to put valuable material underground. So going back to this image, just hidden at the top, but it says elements versus minerals. So minerals become the key in this. And so this area of our business called geometallurgy is particularly important because if we substitute the mineral cobaltite for a different cobalt mineral, so the same amount of cobalt might be in the rock, but we substitute that mineral for a different one perhaps that you can either make by some process or was in the rock in another place, you will get a different result. So geometallurgy is about basically converting what is the element into the and then the further process about what actually goes on downstream in the process. And I can see that actually in our business applying right through to projects such as what's the dust that actually gets formed in a mine? Do we actually know at the moment what dust particles are actually floating around in the atmosphere underground in a mine? Well, hopefully we will. There's a big project to look at that sort of stuff. But it may actually only be tiny grain boundary minerals that are actually contributing to the dust. It may only be 1% of the total rock volume. And we may not see that, and we may not even need to know that or know that until we actually start working back from even the mineralogy of dust. And that's the level that we in our business should be looking at. Now, it was obvious when you were digging up Wittenoom or something like that, that asbestos was forming the dust. That was an easy correlation. But nowadays, we're much more careful in terms of what's underground, how we actually deal with the mining process. So our deep mining process and our friends across in the rest of SMI who are looking at dust need to work together with us, and we need to make sure that we want to work with them in order to provide a predictive tool for mining and the life of the business. So the whole question here is, if we're going to dig things up, when, where and how should potentially useful minerals or elements be stored safe for future use? At the moment, we have this fabulous project where we go out and look at tailings and we recover the material. But if we had actually concentrated those at the outset for a small loss of our value, we would be in a much better position. And we need to think in terms of working with economists as to where we go in that space. So I suppose my general thought about where total deposit knowledge fits in is that every step of our workflow and exploration needs to be assessed in terms of the future value of the process, where value, not dollar value, is a combination of all the components of sustainability. We need economics to make it work, but we actually need the metal as well. And it's very hard at the moment to apply a value to a net zero 2050 carbon credit, for example. But we actually need to think in our business fairly seriously how we actually work with economists and people like that to make this into a workable model. At the moment, we're governed by a set of regulations under the AusIM and under the Canadian system and the South African system that actually drive us to relatively poor behaviour. We sort of need to push back and think about how we actually go there. So what are the tools that we might head towards to achieve this goal? Well, here we are at UQ, research, education, that part of it, but community support, I would regard as even more important because, as I say, we're preaching to the converted. So here's a couple of images to think about in terms of our messaging. The Geological Society of London produced this diagram about the minerals in a smartphone and therefore the elements in a smartphone. And it's a big word cloud. And I'm not sure that putting that on Twitter will actually make any difference to anybody. It's really good for those that understand periodic tables, who love geography, but there is no geopolitical risk or anything like that attached to that image. And there's a bunch of minerals on there that we all love as geologists. And I did notice what I'd say, a glaring error under the rare earth elements. They talk about monazite, and yet they basically ignore the fact that most of the rare earths in China come from not monazite, but a bunch of clays. So there is no real big picture attached to this image. Now, we could adopt an end-use approach to how we actually sell our business and say, compared with an internal combustion engine in the black to an electric vehicle. Interesting that Wheels 2022 Car of the Year is an EV, a Kia. And we can point out that we need more copper, but I'm still not quite sure that that's the answer, because the connection between a little blob on the map like that and understanding that we need a big efficient mine, whether it has an open cut footprint or an underground footprint, is something that we actually need to work on as a group to change. And rare earths look like a tiny proportion, 0.5 kilograms. Now, interesting comparison as you go around this group here, copper and gold and things like that have a market out there that allow you to go to the bank, borrow the money, sell the metal. But something like rare earths, there is not a real market out there for rare earth metals. The rare earth business is actually controlled by the end user. And the fact that it's controlled by the end user, such as BASF or Volkswagen or Tesla or somebody like that, they apply the risk back to the exploration business and the people who want to build the mine. And the result of that is that those things are particularly hard to finance. So if you're Joe investor out here or Jane investor out there, and you want to invest in this wonderful exploration business or mining business, and you look at it and you go, well, the return on my copper gold project is this, and the return on the rare earth project is, oh, crikey, I don't want to go there because I'm not going to make any money. So we actually have this problem at the moment that the critical metal space doesn't actually have a real market for the metal. So it's very hard to promote the exploration business in that space. And yet we really need to do so, because you will probably all know that that business is controlled by one country. Interestingly, this week, there's a BBC series on rare earth. So if you listen to the BBC in the middle of the night, like I do occasionally, you will hear that there's this BBC podcast on rare earth metals. So I'd advise you to go there and hear a little bit about it. Or we can go to this sort of view and say, geology is wonderful. We can do all of these things and we can match them into the UN Sustainable Development Goals. So we put them up here. And as our colleagues have pointed out, we're not actually there. There's all sorts of production of resources that are on this diagram. And just like that circular economy diagram that started, we were left off. That probably says we shouldn't be pointing at them. We should be pointing at ourselves as poor educators of what we do and the value we give to society. So my comment, so I looked up a couple of images just to see if I thought about protests. And here's the converted on the left. And here is the thoughts of the general public on the right. And it was unfortunate to see that image saying in the back, mining has its place, and that place is Australia. Now, that alone says a lot, but this is where we need to build our future, in influencing those people. And I'd like to recount a small story from a friend of mine, Dave Craw. And we were both in opposition in New Zealand to the raising of Lake Manapuri to build a hydropower that fed electricity to an aluminium refinery at Tiwai Point. And in Australia, we have coal mines in Victoria that feed electricity through the transmission lines to a refinery, an aluminium refinery here. Now, as Daniel pointed out to me before, carbon trading might be able to fix some of those issues, but if we don't have that, and the New Zealand one appears to be less profitable, the New Zealand one, which is actually power is sourced from hydropower, is going to be shut down. And here we are going to be left in Australia producing aluminium from coal-fired energy. Now that is a scale problem that we need to fix or think about in the way we explore too. And we need to share our resources, because you can't tell a country that is covered in, say, really young rocks that doesn't have any metals that they can't have them from us, or that somebody else should have them. And we should be working with the rest of the world in our exploration process. Snooze. To actually think about that. So we have a slide here in SMI that says building for the future, like this. And it's what we are doing. But what we actually need in our game also is non-specialist support for that. And that I would encourage all of us here who have the ability to understand that part of the process to engage in mechanisms where we actually receive non-specialist support for what we all love. Thank you very much.
Thank you so much, Nick. That was fantastic, fascinating talk. Do we have any questions in the audience already? Thank you, Anita. I can trust someone.
Yeah.
Always.
No, you didn't know what was going to come out of mine either. So,
thanks for the talk. I guess when we think about EY's sort of risks in mining that came out in September, I guess number 10 was changing business models. So I guess with that sort of being a risk that's kind of creeping in, sort of this recognition to change business models, how do you see that TDK, BRC can sort of assist with that kind of transition to, I guess that's kind of to help sort of support the other risks that were listed there, particularly in the top 3 around decarbonisation and other things?
Yeah, well, I see, I mean, in order to gain support for something like that, we actually need to go to the experts in that field. So I would see people who, we need to operate with the economists and the planners in this institution and build a relationship with them. Now, the issue we have, we look out across the university and what is the support? If you went and polled every person in this institution, UQ, what's the support for mining? We actually need to change that. And I think one way, I mean, for a start, is to show that we actually have this resource efficiency, so we're not wasting products. And we need to move with economists and so forth who actually are a bit more far-thinking than just NPV and say, how do we value that future? I mean, we're not even properly valuing mine closure at the moment, because as soon as you go outside 15 years, a discounted cash flow model, the value's zipped, right? Which is why you keep on increasing the production. So we actually need to think about how to properly value that. And we need to find supporters in the marketplace, both in the financial marketplace and the product use area, that actually support that long-term view. And of course, the refiners all want a long-term business. They want a 30 or 50-year security of supply if you're going to go and spend $1 billion on a hydrometallurgy plant, for example. But if at the other end of the scale, we have the other economists going, you need to make it all and dig it all out of the ground in 15 years, that's actually an interesting sort of issue that we have between even two parts of the process chain further down. So cooperation with people, expertise outside this institution, I would regard as one of the key steps to that. Does that answer?
Yes.
Kim, sorry.
Yeah, thank you very much, Nick. That's touched on some really serious stuff. And this business about selling ourselves to the public is not a new problem, as you know well.
Yeah.
In fact, I was at university doing my undergraduate degree in the 1960s. I'm even older than you are. And we were told at that time that this was a problem for us going out into the industry and we needed to be better at selling. So we've clearly failed completely over the last 50 years plus. What's changed, I think, in a sense, ironically for the better, is the new environmentally aware world that we live in, with a catastrophe that is just on the horizon. Mm-hmm. And everybody's now frightened. And we've got their attention, which we've never had before, because the solution to this problem is, to miss out all the bits in the middle, mining and resources and metals. And the organisation, we talked about it the other day, TDK, has written a wonderful report, and Simon Michaud gave his talk to us a few weeks ago that basically says we're stuffed. We don't have enough metal, so we're all going to die, and it's the end of the world as we know it. Now, that seems to me a spectacular opportunity to go to the 99.99% of people who don't understand mining and say, you've already hooked onto the climate problem. The solutions are all practical engineering material solutions, and they all come from this industry which you purport to hate. So can we do something together to build a view in the public that, in fact, mining is not the problem, it's the solution?
Yes, interesting question, because I had this conversation. My wife, you probably know or may not know, is an environmental historian, and they have groups of seminars. And I said, I'm going to take this view that I have as a video, and I'm going to ask your group to give a critique of what you think it is, what you think I've said, and what you think the solution is. So in part answer to that, I think teachers are unbelievably influential, both at home and for the kids, because the kids go back home, and if their parents don't go, oh, ignore Miss So-and-so, she doesn't know what she's talking about. They actually say, that's interesting. We actually need to give, for a start, teachers and the curriculum the tools that actually allow people to understand it. And those big posters, I would argue, are not the way to do that. We actually need to rethink how we give teachers and education the tools. And I had this conversation with Daniel before to say that we have this issue that there are non-core aspects of things that are taught at school albeit, finance, sex education, something like that. But we're not actually even giving teachers the tools to actually, here's something that you can discuss. You can do it one-on-one, but there's so many schools and things out there that we actually need to get somehow into the curriculum as to where we're going and what we're doing and how it actually fits in to this future that we want to see for our children. Because I'm a bit horrified, and imagine lots of you with kids, that perhaps the future that's coming for them is not as good as ours. And that's embarrassing. Embarrassing as, for me anyway. So there's that aspect. And then there's all the smart people, and I'll say smart people in the rest of UQ. We need to educate the rest of this university as to why we're important. Now, we're failing because you look around Australia and they're shutting down geology departments because they don't have enough students. So we need to change the rhetoric, both so that I think in the teaching space, now I'm not that much in favour of kids actually learning geology at school. I would rather they were given a really good base to a number of arts and sciences so that they actually get a thinking head and a scientific sort of analysis into their thinking. Then they can come to university and do geology. But we need to completely change how we educate teachers and therefore the young people. And then the rest of places like government and University of Queensland.
I completely agree with you. I think my I suppose view is that the climate change problem is the hook on which we can hang exactly what you said we should do. And I think we can cut out a lot of the middle stuff and simply say, you all signed on to climate change. Well, here's the solution. It needs mining. And if I could have a copy of that slide, Nick, that said, because it's such a wonderful slide, where somebody honestly held the view and wrote a large sign saying, it's our future, no mining.
Yes.
Just cross off the no and she'd get it right, or he'd get it right, whoever was carrying that sign.
Yeah, exactly. And I suppose I really want, in my role, I really want to engage with people as to how we actually provide those tools. I felt privileged at my little school in southern New Zealand that we were made to think like that then. And I'm not sure that we're going in that direction at the moment. And don't start pointing. I mean, my thought about, you look out at the social media, don't start pointing at people. Look at ourselves and go, let's answer with the tools to understand. Don't be sharp in criticism for A or B party that they don't understand. That's our problem. We haven't educated them. So resist from the sort of attitude that pervades social media and start thinking about what tools we can answer with in imagery or short videos, even a minute type videos that allow people to share and understand.
We actually got a flurry of comments on online, so I can give people in the audience a chance to come up with a question or two while reading these out. Anna Little Boy says, in terms of representing value to society, would you consider adding in aggregate and sand as a block? And what measures of value do you think we should use?
Well, I'm not an industrial specialist, but the comparison should be made in the way we excavate. But it's not only that. We have a footprint. I mean, in a way, farmers are miners, but not at the scale that we actually see, because you end up with the farmers are taking components from the soil and producing a product. We take more from the soil or the ground and produce a product. So I actually think the answer to that is a slightly bigger one. But of course, going into the farming space is politically fraught, especially here. So certainly some way in which we start discussing, because really you could say there's underground metals mining, small open cuts, big open cuts, coal, industrial. And we don't actually talk about the big industrial pit that produces concrete. We do, but not many other people do. And the CO2 production from concrete is huge, right? But it's not made with the same connection that you have with coal. But we actually should start thinking a little more about each stage of the process and what its real impact is, because there are unseen impacts. I mean, one of the problems, I think, is that the CO2 world is hard to see. Whereas in the Industrial Revolution in London, it was easy to see that the Thames went brown and the fish all died. So they stopped the process, they stopped what they were doing and fixed up the river, albeit it took 100 years. But that sort of, we have that issue with the rate at which the sea level is rising, which is actually huge in a geologist's head, but small in other people's lifetimes. And so this scale issue, I think, is something that becomes a problem. I mean, I've seen photos of people standing in a field talking anti-mining, talking about the pristine environment, and yet they were standing in a picture in a field of canola, which is completely environmentally destructive in terms of the trees and so forth that were there. So we need to be, in terms of that industrial question from Anna, we need to sit down and piece out what the components are. And Daniel's just left to publish that wonderful paper on the industrial world and how it fits in with the Sustainable Development Goals. But we need to think like that, we really do. Thanks, Anna.
Here's a good question. What is the forward plan for TDK itself?
What is the
forward plan?
The forward plan? Well, we need to, without saying too much, I have 5 or 6 projects that I want to work through with the team in December that we actually want to take out to the wider world. And those projects are everything from the production of assays and how we actually measure even comminution at that scale. We can do stuff much earlier in the process. If you consider, here's a quick one for you, that we send everything to ALS and there's, say, 1 million assays go through there a year, and they crush up the rock and give you an assay, and there is no measurement made on the crushing component. None at all. It's just, if you actually measured comminution at that scale, at that time, you would actually get an assay back with a comminution number that actually told you a huge amount. Geologists have this terrible habit, and I think it's a terrible habit, of drilling all these holes and saying, this is a wonderful mineral deposit, and then going, oh, crap, we've got to go and drill a whole lot more to actually do all the metallurgy and all the mine planning. That's really wasteful, really wasteful. So that's one, for example. And I have another one about the interaction between what geologists who have hand lenses do and log core and all the machine world, and how we basically train the machine world to think more like a geologist in terms of what they see and how to apply that back in a much more automated session. Because people like the geological surveys all over the world are scanning their core libraries. What are actually people doing with all that data, and how there's some smart machine learning people out there, but how are they actually applying that data to finding a new ore deposit or working out whether it was a near miss? So those are the sorts of things that I see us going into. So I'd like to see us grow in the same way that the the tailings characterisation MyWatch program grew. It'd be lovely to have a team of 10 postgraduates here or PhD students and funding to actually really improve our behaviour in the early start of the process. So that's where we want to go. We want to improve the geological and deposit behaviour to apply down the track in the process.
We're running out of time.
Sorry.
But there are still a few more questions. I'm going to have to cherry pick and maybe ask the questioners to contact you in person.
Yep, sure.
Maybe I'll finish with one more, and it's a very interesting one. Are there any companies that might be amenable to the approach of a more complete mineral extraction? And if we don't know, how do we identify these companies?
Well, I was really impressed yesterday to listen to the group from Oz Minerals, who have this wonderful, basically thought bubble group, you could say, where they gather information and people give them suggestions and they filter through it and co-fund interesting ideas that will bring on the development. The lack of cooperation, I mean, the big issue in our business is the lack of cooperation. So we go to party A and they say, we'll give you $100,000. Party B says, we'll give you $100,000. Oh, we've got 200. Oh, no, you don't have 200,000. You can't tell them what they are doing. So that is actually an issue for our business. So a bit more cooperation would be good. But I would have said, and I've only been here 4 weeks because, of course, I had a different job before. So having been in a couple of board meetings and in this meeting yesterday with the industry GSQ, there are people out there at the big end really thinking about that stuff, and they can afford to. But the junior space, we need to provide the tools to allow them to do it at low cost, because their thought base is not. Their thought base is survival. The big businesses are out there with production, income, all of those sorts of things, whereas the junior world is all about producing a result to the market and finding something, but producing a result to the market that actually provides value to their business, because essentially the speculators funding what they're doing. So we actually need to provide tools that allow their business to be better and fit into that larger framework.
Very good. Well, so we will have a transcript of all of the questions, and maybe perhaps you could answer the questions personally to those who asked them. So before we part for the day, next Friday, we are hosting Alex Wilson from Minerva Intelligence, who are based out of the Vancouver office in Canada. And he will talk about automatic block modeling using locally adaptive machine learning. And it will be a seminar over Zoom, but please join us in the lecture theater. Nevertheless, thank you very much, Nick. Fantastic.
Thank you. Cheers.
Fantastic.